Hi everyone, so this lesson is on expanding brackets, and before we get into it, I want you to try to remember the 4 conventions that we have learned so far when we write algebraic expression, and I've given you 4 clues here. So pause the video and see if you can remember the 4 rules or conventions that we have learnt. Okay, so I'll go through them now. We'll see if you've got any of them. So the first rule or convention we learn is that when you multiply anything in algebra, we don't need to include the multiplication symbol. So we take out the multiplication symbol. So 6 multiplied by a would just be written as 6a. The next convention that we learn is that when we write terms that have variables and numbers in them, the number must come first. So to write A6 down on the page would not be correct. We would need to write 6A, like in the first one. So the first rule is that we don't include multiplication symbols, and the second rule is that numbers come first in our terms. This next rule, or the next convention, is that when we have multiple variables in one term, we should be putting them in alphabetical order. So 6 A, B, C, D, E would be the correct way to write this, because all of my variables are in alphabetical order. And the last convention is that if we just have one of the variables, we don't need to write 1B if I just had 1B. I just write the letter B by itself. So that is one that's easily forgotten, is that we don't need to put the number 1 as a coefficient here. Just writing B means we have 1B. So in this lesson, or at the beginning of this lesson at least, we're going to be using this convention quite a lot. So where we are removing multiplication symbols when multiplying things together. So we're going to go through some examples now, so copy these into your book. In fact, the first 3 questions in this example you should be able to do by yourself, because they came up in earlier lessons. So have a go at these now, pause the video. Okay, so you should have got 3 answers here. For the first one, we should have got 5a, just simply removing the multiplication symbol, 5xy, and 5axy. For the second 2, we just needed to make sure our letters were in alphabetical order. I mean, they already were to begin with, so that's good. And the main thing is that we were removing the multiplication symbol and also making sure the number was first. So in fact, we are using 3 of those 4 conventions that we just looked at. Now these next 3 examples you should also copy down. So if I am to multiply 2 numbers together, like in this example 5 times 7, we wouldn't just simply write 57, right? When I do 5 times a, like in the first example, I just take out the multiplication symbol and put the 2 things next to each other, 5a. But that doesn't work with numbers, because 5 times 7 isn't 57, we know that it's 35. So if we're multiplying 2 numbers together, we have to actually use brackets to show that these 2 things are being multiplied together, because we know that it's not correct to write 57 like that. It has to be written like this to make any sense. And we know the answer is 35, but we're not trying to practice times tables here. So if I had 5 times 102, I wouldn't just put 5102 as my answer. It would have to be 5 and then in brackets 102 to show that these 2 things are being multiplied together. Because we know 5 times 102 is not going to be 5,102. And then for this last example, I have 5 times and then 21 plus 6. So again, I can just take out my multiplication symbol and put my number right next to the bracket, but I wouldn't just be writing 521 plus 6, for example. So if we have variables, like in the first 3 examples, we can just remove multiplication symbols. And if we're dealing with numbers, we need to actually use brackets to show that 2 things are being multiplied together. So we're gonna take this a little bit further now and look at some algebraic area models. And you should also copy these into your book. So we can represent these multiplications that we just looked at. So these multiplications, 5 times a, 5 times xy, 5 times 7, we can represent these multiplications using area. And we know that the area of a rectangle is found by doing the base of the rectangle multiplied by the height of the rectangle, base times height. It's a really simple and easy formula. So if I take my first example, 5 times a, I can construct an area model looking like this. So it's just a rectangle where I've labelled the base as a and the height as 5, and then my actual area would be 5a. So this is just another way I can represent this algebraic equation. If I had 5 times xy, I can construct a different area model with a different base. It happens to have the same height, and the area of this rectangle would be 5xy. So I can use area to help me find the answer to these questions. And if I'm going to get you to draw some of your own area models, algebraic area models. So pause the video and you're going to have a go at these questions. Make sure you've got your area models for each one. Okay, so I don't have space on the slides to put in the area model, so I'm just going to give you the area of the rectangles that you should have drawn. So for the first one, we should have had 4b, then 7y, then 21b, kj, making sure our letters are in alphabetical order, 2ab, 10cp, 4ar. This one we did have to switch the order of the letters. We should have had 10r squared, and we should have had 18p squared. So you should have lots of lovely area models on your page showing the area of different rectangles that have different side lengths. And now we will look at some numerical area models. So we've seen these before as well. When you learn how to do the grid method to multiply numbers. So if I have 5 times 7, for example, I can make an area model 5 with 5 as the height and 7 as the base, and then my area I'm going to represent with brackets 5 multiplied by 7. And we know that that's 35, so we can write 35 in here. This one, 5 times 21, I can actually, to make this easier for myself, partition this number. So 21 can be partitioned and broken up into 20 and then plus 1. I hope you can see the connection there. Now the area model for this will look a little bit different because I've got 2 terms here. I've got 20 and plus 1. So this time my area model will look like this. I've got one rectangle for 5 times 20, and I've got one rectangle for 5 times positive 1. And I have been very careful to make sure I've got my positive there, just in case, this will be useful in the future, making sure you've got your positive sign in your area model. So this area model is now a little bit easier to fill out. I know most of you would be able to do 5 times 21, but we're pretending that we can't. So in this area model, we'd end up with 100 for the area of this rectangle and positive 5 for the area of this rectangle. So to find the answer to this question, we would just add these 2 things together. And again, I was careful to put my plus 5 here because that tells me to do 100 plus 5, which is 105. So these are what numerical area models would look like, these 2 examples here. So we're going to look at a few more a few more examples of this, like this second one where we partition the number up. So these ones you should copy into your book. You didn't have to copy the last two. So if I was trying to do 3 times 225, I know that I can show that with brackets like this. 3 brackets 225. I'm then going to help me do this a bit quicker, I'm going to partition this number 225 up within the bracket. I'm going to partition it to 200 plus 20 plus 5. And now my area model is going to have 3 rectangles in it, because I've got 3 terms, 200, positive 20 and positive 5. So this is what my area model will look like. 3 multiplied by 200 plus 20 plus 5. Completing the area model, it looks like this. So we have 600 plus 60 plus 15. And then to work out the final answer, we just add these things together, and that gives me 675. One more example. If I wanted to do 7 multiplied by 108, that can be shown with brackets, so 7 bracket 108. And I'm going to partition 108 up into 100 plus 8. So the area model for this problem will have 2 rectangles in it, because I have 2 terms inside this bracket, 100 and positive 8. So this is what the area model would look like. And completing the area model looks like this, 700 and positive 56, and those would add together to 756. So even though you might be feeling at this stage, why are we doing this? And it will become clear later on when we're doing some expanding brackets questions, and especially when we are factorising some expressions. So bear with me, even if you feel like this is a little bit weird to be doing in an algebra lesson. You're going to pause the video now and have a go at these practice questions. I want you to practice partitioning a number like this, using an area model to find an answer. So off you go. Okay, I'm not going to give you the answers to these because you can check those on a calculator, but hopefully you've got some nice expressions like this where you have partitioned your number using brackets inside the bracket, and a nice area model for each. So now we're going to try and link this to our lesson in algebra, which is expanding brackets and factorising expressions. And we can use these grid methods and our area models to help us do this algebra. So I'm just going to show you a numerical example again. You don't need to copy anything from this slide out. You just listen. So if I'm trying to do 6 multiplied by 32, I can show that with brackets like this. Now we've just learnt that we can partition 32 up and within that bracket into 30 plus 2. And with a nice area model, which I've got over in the corner here, I can find my answer. Now this applies to algebra, or links to algebra, in a really nice way. So if I now show you this expression, 6 multiplied by a plus 2, and a plus 2 is in the bracket, and we can just think of a plus 2 as a number, just like 32. It's just a partitioned number where a is an unknown and we don't know what it is. Okay. Now I can use pretty much exactly the same area model that I used for the previous one to help me find the answer to this. So for this one, my area model is almost identical, where in the place of 30 though, I have the variable a. And within my grid, I have 6a for the area of my first rectangle, and positive 12 as the area of my second rectangle. And just as I did in the previous one, to get my answer, I need to add these things together. So to get my answer to this question, I need to add these 2 things together. So the answer to this question is 6a plus 12. Another example may be this one. So this time I'm doing 6 multiplied by 5a plus 2. And again, you can just think of 5a plus 2 as a partitioned number where we don't know what the a is, Remember, the whole point of algebra, if we think back to our very first lesson on variables, is that variables just represent numbers we don't know. So A is just a number we don't know, but if we did know it, we could even just write it like this. But anyway, a really similar area model again, where we have 6 multiplied by 5a plus 2, and the area of our first rectangle would be 30a, and our second rectangle would again be positive 12, and just as in the previous 2 examples, to get our answer, we would just add the things up that are inside the grid. So the answer to this multiplication, 6 multiplied by 5a plus 2, is 30a plus 12. Now, this process that we've just done in the second 2 examples, in the algebraic examples, is called expanding brackets. Okay, you're given a question where you've got something multiplied by a bracketed expression. So here we've got 6 multiplied by this bracketed expression, and here we've got 6 multiplied by this bracketed expression. And you use your area model to expand those brackets and get a different expression. Now, expanding brackets, I like to think of this as eliminating the brackets. I would write that down if I were you, somewhere on your page, that if you're asked to expand the brackets, you're being asked to eliminate the brackets. Because that's essentially what we've done, isn't it? 6 bracket a plus 2 is identical to 6a plus 12. So we've got an expression that's exactly the same, it's identical, but there's no brackets in it, we've eliminated them. So hopefully this process is quite clear to you and you can see where this all comes from, especially using these area models. So I'm going to get you to copy these examples in your book. You didn't need to copy the other ones. So we want to expand the brackets in these expressions. And remember, we may have just written down that expanding the brackets means we need to eliminate the brackets. And we're going to use area models to do this. So for this first one, 4 multiplied by x plus 9, I have an area model that looks like this. And I've still got my positive 9 here. That's going to be really important in a second when we deal with some negative examples. And then I'm going to fill out my grid, so I'll have 4x and plus 36. And then remember, to get your answer, you just add up whatever's inside your grid. So we would get 4x plus 36. Our next example, we're going to have 2 multiplied by this bracketed expression, 8g take away 5.2. So we want to eliminate these brackets, and we will use an area model to help us get our answer. So 8g. And then you can see now that I've got negative 5.2 here. And it's really important when we fill out this grid, it's really important to put if it's a positive or a negative there. Because when we fill out the grid, we're going to have positive 2 times 8g. Fine, positive times positive is a positive. But now we will have in our second rectangle's area, positive 2 multiplied by negative 5.2. And obviously I've just gone and got that wrong. I'm going to have to change it. Can't have it as incorrect. Where are we? Here we are. Okay. Right, so negative 10.2. So positive times by negative makes a negative. And that's why it's so important to put what your symbol is. And you will be multiplying some really complicated bracketed expressions soon, so please make sure you've got your positive or negative symbol there. Okay, so the answer to this one was 16g take away 10.4. And one more example for you to copy down. We're doing 6 multiplied by the bracketed expression, 11 take away s. Our area model would look like this, 6 as the height of our rectangle, and then 11 take away s as the base of the 2 rectangles next to it. When we complete the area model, we're going to get 66 and then negative 6s. And our answer will be 66 take away 6s. So those are 3 examples, and you're going to have a go at these practice questions now. Please draw an area model for each question in these examples. Okay, so pause the video and have a go at these questions. Okay, so again on the slide I don't have too much space to draw these area models, but I can show you the answers for when we have expanded the brackets in these expressions. And remember, expanding the brackets is just eliminating the brackets. So in our first one, we should have 3p plus 15. Our next one should be 9t subtract 90. In our next one, 1000x subtract 2000. In our next one, 20 take away 4k. Next is 30m subtract 15. Next is 0.7r plus 35. Next is 5k plus 2. Next, this one's a little bit different, isn't it? Because it has 3 terms. So this one would have had an area model with 3 rectangles in it. But we should have gotten 2a plus 2b plus 10. Next, we would have 2yz plus 50. Next is 2r take away 1/3. And this next one is really testing if you remember how to multiply fractions. But multiplying fractions is one of the easier things to do with fractions. You just multiply your numerators and multiply your denominators. So you should have gotten 4 over 15r take away 1/4. You might have something different to 1/4 here. You might have 3 over 12. But that means you needed to simplify that fraction. So 3 over 12 simplified is 1/4. So hopefully that made lots of sense to you, and you're going to have a go at section A and B on the sheet, and then if you finish that early, then there is an extension question here for you to have a go at. So in 5 seconds I will reveal the answer to the extension question. I don't want to spoil it for anybody, but I know lots of you asked me for the questions to these extensions, so I'm going to reveal the extension question now, the extension question answer. So if you had a go at that, then this was the answer to that question.